Gold has fascinated people for thousands of years. It has been used as money, jewelry, a symbol of power, and one of the most valuable materials on Earth. When most people picture gold, they imagine gleaming bars stacked inside heavily guarded vaults. But those bars don't come out of the ground looking like that. In fact, transforming raw gold ore into a perfectly shaped gold bar requires mining, extraction, refining, melting, and rigorous quality testing. How are gold bars made? From tiny particles hidden in rock to polished bullion bars, the process is complex and precise. How does raw ore become one of the world's most recognizable symbols of wealth? Let's dive in, right here, on History of Simple Things. The journey begins at a gold mine, where miners extract gold-bearing ore from the earth. Gold can be found in underground deposits, open-pit mines, or river sediments known as placer deposits. Modern mining companies use geological surveys, drilling data, and advanced mapping technology to locate areas with economically viable gold concentrations. Once a deposit is identified, large machinery removes tons of rock and soil to reach the ore. The extracted material is then transported to processing facilities where the gold can be separated from the surrounding rock. Surprisingly, most gold ore contains only a tiny amount of actual gold. In many cases, a ton of rock may contain just a few grams of the precious metal. Because of this, enormous quantities of ore must be mined and processed to produce even a single gold bar. The efficiency of extraction methods plays a major role in determining whether a mining operation is profitable. After the ore arrives at the processing plant, it undergoes crushing and grinding. Massive industrial crushers break large rocks into smaller pieces, and specialized mills grind them into a fine powder. This increases the surface area and makes it easier to separate the gold from other minerals. One of the most widely used extraction methods is cyanide leaching, where a dilute cyanide solution dissolves gold particles from the crushed ore. Although cyanide is highly toxic, modern facilities use carefully controlled systems and environmental safeguards to minimize risks. Once the gold dissolves into the solution, it is recovered through processes such as activated carbon adsorption. The carbon attracts and captures gold particles from the liquid. The gold-loaded carbon is then heated and treated to release the metal. At this stage, the recovered material is still far from pure gold. Instead, it contains a mixture of gold, silver, and various impurities that must be removed before bar production can begin. The next step is refining, where impurities are removed and the gold is brought to an exceptionally high level of purity. Refineries use several techniques depending on the desired purity and the composition of the material being processed. One common method is the Miller process, which involves blowing chlorine gas through molten gold. The chlorine reacts with many impurities, causing them to separate from the gold. Another widely used method is the Wohlwill process, an electrolytic refining technique capable of producing gold with a purity of 99.99% or higher. In this process, electric current passes through a gold-containing solution, causing pure gold to deposit onto cathodes while impurities remain behind. Refining is one of the most important stages because investors, central banks, and financial institutions demand precise purity standards. Even a tiny variation in composition can affect the value and acceptance of a gold bar in international markets. Once the gold reaches the required purity level, it is melted and prepared for casting. Industrial furnaces heat the metal to temperatures above 1064 degrees Celsius, which is gold's melting point. Workers carefully monitor the process to ensure the molten gold remains free of contamination. During melting, technicians may take samples to verify purity and composition before the metal is poured into molds. The molten gold appears as a bright, glowing liquid with an intense orange-yellow color caused by the extreme heat. Because gold is dense and valuable, strict security measures are maintained throughout the process. Access to refining and casting areas is heavily controlled, and detailed records are kept for every batch. At this stage, the gold is ready to take on the familiar bar shape. But achieving consistent dimensions and weight requires precise handling and specialized equipment designed specifically for precious metal production. The actual formation of a gold bar occurs during casting. Molten gold is poured into heat-resistant molds, usually made of graphite or cast iron, where it cools and solidifies into bar form. The cooling process is carefully controlled to maintain quality and prevent surface defects. After casting, each bar undergoes inspection and testing to ensure it meets industry standards. Refineries use methods such as X-ray fluorescence analysis and precise weighing systems to verify purity, composition, and weight. Bars that pass these checks are stamped with important details, including weight, purity, the refinery's mark, and a unique serial number. Some remain as cast bars with a rough appearance, while others are refined into minted bars with smooth surfaces. Once certified, the gold bar becomes a standardized asset suitable for investment, storage, and international trade worldwide. The creation of a gold bar involves much more than simply melting gold into a mold. It starts with mining gold-bearing ore, followed by extraction, refining, casting, and quality testing. Each step ensures the final product meets strict standards for purity and weight. What begins as tiny traces of gold hidden in rock eventually becomes a valuable gold bar ready for investment, storage, or trade. From deep underground to secure vaults, every gold bar undergoes a remarkable journey before reaching its final form. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.